the 17-kilometer transnational wonder. Lafarge Long Belt Conveyor. Meghalaya, better known as the abode of the clouds, is a source of inspiration, a dramatic canvas that is every artist's dream, and the ideal retreat for people in search of beauty and solitude. Bordered by Assam in the north and Bangladesh in the south, Meghalaya has the toughest terrains and the highest hillocks in the Indian subcontinent. It is one of the wettest places in the world with very heavy rainfall. No one would ever imagine setting up an ambitious industrial project in this terrain, which is geologically a challenging work spot that experiences extreme weather conditions. Especially if it were to be a technically unique and challenging project involving innovation, unconventional logistics never attempted earlier. What then does it take to design and construct a project of this type? Well, it takes an architect of many a technological marvel. India's largest engineering and construction conglomerate, Larsen & Toubro Limited. Presenting the Lafarge Long Belt Conveyor. Originating from the foot of the East Khasi Hills of Meghalaya in the Himalayan range and culminating in Chatak, Bangladesh. A project executed by L&T on engineering, procurement and construction basis. This overland conveyor for the Lafarge Surma Cement Limited is the longest single-flight belt conveying systems in the world, traversing 2 countries. It exports 1.2 MTPA shale and limestone mined from the reserves of Meghalaya, India, to the Lafarge cement plant at Chatak, Bangladesh. The design and construction of this cross-country conveyor project is a unique concept and first of its kind in the world due to its length and height, horizontal and vertical curvature and contour without having any transfer tower. This engineering marvel is 17 kilometers long and has a belt width of 800 mm. 7 kilometers in India and 10 kilometers in Bangladesh. It travels above ground at elevations varying from 6 meters in the plains to 44 meters in hilly terrains, including 1.6 kilometer stretch of geological fault area, making it highly complex in design and construction. This wonder project created by L&T involves setting up an entire belt conveyor system, crushing system, construction of powerhouse, installation of diesel generators and auxiliaries, design and construction of complete civil, structural, mechanical and electrical works. The system is designed such that the bigger size limestone and shale sourced from the mines are crushed at the primary crushing plant into small pieces. Through a small conveyor, it is fed to the secondary crushing plant where it is cut to the required size. Final size materials are then discharged to transfer towers on the Indian side. From there, it travels through the long belt conveyor and reaches the transfer towers stationed at the cement plant in Bangladesh. The Engineering Design and Research Center of L&T offered its design expertise with basic engineering from Aumont, France. The design and construction method for the foundation in the hilly areas was drawn up with special care, considering the seismic topography in the hilly area. The conveyor system is driven by a dual variable voltage variable frequency VVVF drive at the head end and singular VVVF drive at the tail end. These drives are operated in a fully synchronized mode. There are no walkways along the entire route of the conveyor system. Instead, it is installed with innovative, moving maintenance vehicles at both the countries for inspection and maintenance. These specially designed and imported vehicles have speeds up to 20 kilometers per hour and are fitted with wireless communication facility. The entire project comprises 300 structural steel galleries and 6 bridges on the Indian side and 378 galleries and 6 bridges in the Bangladesh area. These 12 long-span steel bridges span across the river and connect the road crossings. The erection of 100-meter-long, 135-ton heavy steel bridge for the river crossing across Maula and another in the fault zone was critical and an engineering challenge. The erection of bridges involved engineering, fabrication, supply, assembly and erection of steel structures using temporary supports. As no cranes could access the location, various lifting devices and erection methodologies were adopted. After necessary alignment and welding, temporary support structures were dismantled and galleries were installed. Execution of this unique project posed many challenges: unconventional nature and geo-fault line, massive terrain, tackling of water bodies, and floods due to heavy rainfall. Since water bodies had to be tackled, boats were used for the first 8 months to ferry men and materials, and then a temporary bridge was constructed. To add to all this, the project witnessed a rainfall that was the heaviest in the last 32 years in Cherrapunji, causing devastating floods in Bangladesh and hampering progress of work. Even with just a light shower, the entire work stretch would turn into a lake of stagnant water with knee-deep slush. These challenges were ably met with a perfect logistics planning, systematic supply chain management, and efficient project management that only a company like L&T can bring into play. In all, the Lafarge Long Belt Conveyor stands tall by contributing to the industrial development of the northeastern region of India. It has linked 2 nations and cemented the special relationship they share. It is Imagineering at its best and a mighty achievement for L&T. Truly, this 17-kilometer transnational wonder has made both the country and L&T proud.